homework 3.2, which is transformations homework 2, has some tricky problems on it. Overall, what we're dealing with is the general transformations y equals a times f of c times x minus h plus k. And so real quickly, what all of these things do is f is the function. So maybe it's like square root or x squared or something. This is the function. The stuff outside of the function is usually pretty easy. The plus k is a transformation up or down. It's a translation up or down. The a is a vertical stretch by a factor of a. If a is less than 1, the absolute value of a is less than 1, it'll be a vertical compression by a factor of a. And if a is negative, it reflects the function across the x-axis. What's going on inside of the function is these will be all horizontal changes. X minus h, the reason it's written as minus h is because it's backwards by what you would expect it to be. It's a horizontal translation by h, but if it's x minus 2, it goes to the right by 2. If it's x plus 7, it's a translation to the left by 7. The last one, and the weirdest one, is c. c is a horizontal compression by a factor of c. If c is 2, there's a horizontal compression, and another way to think of it is all the x values get divided by whatever that c is. So you take all the x values and divide them by whatever c is. That's how it gets horizontally compressed. If c is less than 1, when you divide by a number less than 1, it'll actually end up horizontally stretching it. So let's look at how this gets applied in some of the trickier situations. Number 3, I think, is the hardest one on your homework. And I think in one class we didn't even get all the way to ones like this. So let's see. The first thing is that it's not written like we're used to having it written in the transformation form. And so we're going to rearrange this. Usually there's not a 4 at the beginning. And so remember that if you have a minus b, that's the same thing as negative b plus a. So this 4 minus whatever, the minus goes with this. The 4, we can actually rewrite this as negative this guy plus 4. So we're going to rewrite this as negative square root of, and I'm going to come back to this in a second, plus 4. The other thing that's weird is the order of operations. For the transformations to work, it needs to be x minus h happens first, and then the c gets multiplied. And in this case, the c is getting multiplied before you have the number being added on, and that's an order of operations issue where it won't do the transformations you think it will do until you rewrite it. What we need is this c to be multiplying times the whole thing in there, and so what we're going to do is we're going to factor out the 1/2. It's 1/2 times, well, 1/2 times x gives you 1/2 x, and we need 1/2 times something to give us 3, and that's going to be 6. So what we've done is we've rewritten this original function in this transformation form, and now we can graph it. The parent function for square roots looks like this, and this is y equals square root of x. The translations were 6 to the left and 4 up, so it's translated 6 units left and 4 up. We also have a horizontal compression by 1/2, or stretch by a factor of 1/2, and a vertical reflection. So instead of the square root increasing, the square root will be decreasing, and the x values will be stretched over by a factor of 1/2. The easiest way to think about it is 1 divided by 1/2, which is 1 times the reciprocal, which is 2. Because this is less than 1, the horizontal values will be stretched by a factor of 2. So normally when x is 1, y would be 1, because the square root of 1 is 1. However, the x value got stretched by a factor of 2, and the y value got reflected over the x-axis, and so we end up with this horizontal stretch. The next x value would normally be at x equals 4, because the square root of 4 is 2, but instead of being at 2, it got reflected to down by 2. And instead of being at 4, the x values get stretched out by a factor of 2. So instead of being at 4, 2, it's going to be at 8. 1, 2, 3, 4, 5, 6, 7, 8 away from the vertex. It'll be down by 2. The next number we can do the square root of is 9. Normally we would have square root of 9 away from the vertex. We'll be up by 3. Now it'll be down by 3, and instead of being at 9, it'll be at 18, which is off the graph already. So this is what our function is. This is y equals 4 minus square root of 1/2 x plus 3. That's a tricky problem. On the back, I'll do number 6. Number 6 is clearly a quadratic. We see there was a horizontal translation to the left by 5. We should also see that normally parabolas open concave up. It got reflected. And finally, normally when you do 1 squared, it would be 1. And this clearly is not 1. So there's going to be a vertical compression here. So the equation is going to be y equals negative, we're going to fill in this number in a second, x plus 5 squared. And this takes care of our translation, 5 to the left. This reflects it across the x-axis. We need to figure out what number this is, and it's hard to tell. Maybe it's 1/2, maybe it's 1/3. So I'm going to go to this next point because it's much easier to see. Normally, 2 squared would be 4. However, it only went by 1. So 2 squared is 4. The factor must be 1/4. Y equals 1/4 because when you do 2 squared, that's 4. A fourth of 4 is 1, which is where this is at. And we can double check another one. When we go over by 4, 1, 2, 3, 4, normally 4 squared is 16. A fourth of 16 would be 4, and it is down 1, 2, 3, 4 right here. So this is the correct factor. The last one I'm going to do is number 9. It says f of x, which is this original function. We're using the same f of x for each of these 4 problems. F of x is getting vertically stretched by a factor of 3. Well, if you vertically stretch something by a factor of 3, the new function is going to be 3 times the old function. What makes this a little bit tricky is that the original function was a binomial. Because of this minus, we have 2 times this absolute value function, that's the first part of the binomial, minus 5. And so when we multiply by 3, it distributes. So g of x is going to be 6 absolute value of x minus 3 minus 15. Notice that the 3 multiplied by both the first term and the second term. Notice too that it does not multiply inside of the absolute value. If you have 3x and you multiply this by 5, you don't get 15 times 5x. It doesn't distribute because these are multiplying. There's no distributing. You only distribute when there is a subtraction sign. And we're not distributing here because this was 2, think of this as 2 times a. A is absolute value of x minus 3, and so when we multiplied, we just multiplied by the coefficient. So, I hope this helps.